Metal joining and welding processes. While it is not mandatory that the inspector be a qualified welder, any hands-on welding experience is beneficial. In fact, many welding inspectors are selected for these positions after many years in the welding field. History has shown that former welders make good inspectors. Another benefit of having experience with these welding methods is that the production welders have a great respect for the inspector, and possessing this knowledge will help the inspector gain cooperation of the welders and for the people involved in the fabrication operation. The welding processes we'll discuss will be the shielded metal arc welding, which is referred to as stick, the gas metal arc welding, referred to as MIG, flux core arc welding, gas tungsten arc welding, referred to as TIG, and sometimes you'll hear it referred to as heliarc, submerged arc welding, plasma arc welding, electrode slag welding, oxyacetylene welding, stud welding, laser beam welding, electro beam welding, and resistance welding. And the brazing processes we'll discuss is the torch brazing, the furnace brazing, induction brazing, resistance brazing, dip brazing, and infrared brazing. And the cutting processes we'll discuss is oxy-fuel cutting, air carbon arc cutting, plasma arc cutting, and mechanical cutting. And note that there are over 100 different welding processes, but we're going to discuss these few because these are the ones that are widely used in the welding field. Take a second and identify this process. This is the shielded metal arc welding process. As the welding arc progresses to the right, it leaves behind a solidified weld metal covered by a layer of converted flux, referred to as slag. And know that the American Welding Society has developed a system to identify these electrodes. The letter E refers to electrode. The next 2 digits, and sometimes 3 digits, refers to the tensile strength. And note that the 70 is 70,000 pounds per square inch, which is the minimum tensile strength required. The next position would be the 1, which lets me know I can weld in all positions except vertical down. If I want to weld vertical down, I change the 1 to a 4. The next digit is the 8, which is the coating and operating characteristics. And when they're referring to operating characteristics, they're referring to the polarity you can run. And with this electrode, the E7018, the 8 lets me know I can weld alternating current and DC electrode positive, which is referred to as reverse polarity. And note that it is important to note that rods that are ending in 5, 6, and 8 are low hydrogen electrodes. And any low hydrogen electrode which are not to be used immediately should be placed in a holding oven as soon as the airtight container is open. Most codes require that low hydrogen electrodes be held at a minimum oven temperature of 250 degrees Fahrenheit after removal from their seals or containers. One of the limitations of shielded metal arc welding is the speed. It is a slow process, and the electrodes that are being used are usually 9 to 18 inches long, and you have to constantly remove and change these electrodes. And also you have the potential with this electrode to get porosity and arc blow. And there's many methods to eliminate arc blow or reduce it. First, change from DC to AC. Hold a shorter arc length. Reduce welding current. Angle the electrode in a different direction. Use heavy tack welds. Weld toward the heavy tack. Use a back step technique. Weld away from the work connection to reduce back blow. Weld toward the work connection to reduce forward blow. Attach the work cable to both ends, or you could wrap the work cable around the workpiece. That would help reduce the magnetism. Since shielded metal arc welding is a primary accomplished manually, there are numerous discontinuities that can occur. You can get incomplete fusion. You can get incomplete joint penetration, cracking, undercut, overlap, incorrect weld size, and improper weld profile. And there's other discontinuities you can get, lack of fusion, and others. But we'll discuss that later on through the discussions. Take a second and identify this process. This process is called gas metal arc welding, which is referred to as MIG welding. And the American Welding Society has also developed a system for identifying these electrodes. Let's take a second and identify the first two letters, which is the ER, which stands for an electrode or rod. So this can be used as an electrode or a wire. The next two numbers refers to the strength, as similar to the 7018. It's 70,000 pounds per square inch. It's the minimum tensile strength. The letter S lets me know that's a solid piece of wire. And the next position is the chemical composition. With gas metal arc welding, there are 4 basic modes of metal transfer. The hottest type transfer is spray, then you have gobbler, pulse, and your coldest type transfer is your short circuiting. Take a few seconds and look at the diagram below. Your hottest type transfer, spray, can be achieved when using at least 80% argon. Argon CO2 is probably the most popular gas used when welding carbon steel using a gas metal arc welding process. Then you have the gobbler type transfer, which is almost as hot as your spray, but its operating characteristics tends to be less stable, resulting in increased spatter. And your coldest type transfer is your short circuiting type transfer, results in the least amount of heat to the base metal, making it an excellent choice for welding of sheet metal and joints having excessive gaps due to poor fit up. The short circuiting type transfer method is characteristically cold due to the electrode actually coming into contact with the base metal, creating a short circuiting for a portion of the welding cycle.